Hey all, today we're going to talk about scoping some variables. So, variable scope can be a little bit confusing. I promise I'm going to break it down as best I can here. Should be noted, this is a topic that will occasionally get you even after you're a pretty experienced coder. So, let's talk about kind of the places that we could find variables. So, here I've got my little code snippet and I've got my class main. That's just kind of our sort of standard. We're starting out writing some code. We're going to have a main class. Um, this is a spot where I can declare something that's like almost a global. We don't really have globals in Java. So the closest we can get is kind of declaring a class variable in main. So this conversation is going to have a lot of stuff in it. So I'm going to be doing a little more copy and pasting, so you don't have to painfully watch me type. So up here at the top, outside of the main method, but in the main class, I've declared a static integer that I'm calling test number. This is our true class variable. We don't have globals here. If you've had the intro programming class where we sometimes use a language called processing, processing is built on Java. And so you might ask yourself, like, hey, I remember using global variables there. Like, what's the deal with that? Processing is itself a Java object. And so its class variables are those globals. They're not truly global variables in Java. In processing, they are because you're always stuck in the processing object. You kind of can't get out of it. So this is my class variable. This is kind of the most accessible a variable can get. Then I've got my main method here. So in here, I'm going to go ahead and create another version of that same variable. So here's me making a variable called test number. So that's the same name, you'll notice. This one's local to main. If I comment this one out, I get some like issues raised with the first one. So let's see what we're getting here. Okay, so in main, test number is 0. That's because in here, it looked for a local version of this variable. It didn't find one, so it went to the class variable. If we comment this line back in and run this, it's going to look for test number, and it's going to go ahead and find the local version. Notice that IntelliJ does a little bit of helping me here. It's saying, all right, this thing turned purple. It's like, did you mean to use that one? That one's got a slightly funny scope for what you're trying to do. So I'm going to put this back to the local version. So here we're saying in main, our test number is test number. We're going to see here that in main, test number is 1. So the next thing I'm going to do here is I'm going to go ahead and I'm going to make a little bit of a test method. So I'm just going to paste in my test method here. So I've got a public static void test method here, right? So that's a test method that's not expected to return anything and doesn't take any parameters. Okay, so this guy just has in it, in the test method, test number is test number, right? We're just printing out test number again. Now, which test number is this going to use? This is going to try to find a test number in itself. There isn't a defined variable called test number in here. And so then you might think, oh, well, it's just going to go grab this one. Well, these are both methods, so they're sitting at the same level. This guy is going to go up a level, which is into the class, and that's where it's going to find that test number. Now, when I hit run on this, you might expect this to actually print something out. So let's hit run on this and prove that it doesn't do that. Okay, so test number is 1 here. And the reason for that is that I haven't actually called this method at all. So down here in main, right, this is the only method that's running. So right now we just ran this. It's printed scope, and it printed out the results of this print statement, right? That's why I see test number is 1. Now, if I want to actually go ahead and call test method, I'm going to actually go ahead and do that. And then let's hit run here, and we'll see that we get in test method the test number variable contains a 0. That's because this test number variable is referencing the class test number variable and not the one that was in the main method. Okay, so as our next thing, I'm going to go ahead and do something a little bit similar. So I'm going to make a new test method. This one's going to have a local variable in it. That's here, I'm declaring and initializing a local variable test number. That test number is 2 in this case, essentially because this is the second method I've written that has a test number in it. And then here we'll see we get this print statement. When we run this, I want you to spend a second and think about what you expect to happen right now. Yeah, nothing should change. I wrote this method, but I never called it. And so because I never called it, it's not doing anything. So let's go ahead and get some code to call that. So I'm dropping in some code that calls the test method with local variable. And so now we should see here, we've got in main the test number is 1. That's from this guy. In our test method that doesn't have a test number variable in it, this one gets the class variable. That's where we get this guy. In test method with local, I get a test number of 2 because that one has its own version of test number inside of it. Notice none of these are conflicting. They're not throwing errors. This is perfectly expected behavior. It's a little weird behavior, especially if you're new to programming, but this is how you would hope it behaves. Okay, let's check out the version where we say make test number a parameter for a function. So here I'm going to give myself another test method. Okay, so my test method now is a test method with a parameter. So this takes an integer that I'm calling test number. And here we're kind of wondering what's going to happen. My claim is that this is actually virtually identical to the previous one. The reason this is virtually identical to the previous one is when I get this integer test number passed along, this thing, the like back end of this basically says, all right, I need a variable that I'm going to call test number in this local spot. I'm going to call that test number, and I'm going to put whatever number I received from the function call in there. That's going to go ahead and just essentially repeat this process. So essentially we're seeing this line duplicated in here, except the equals whatever part doesn't happen until the function is actually called with that parameter passed to it. So let's go ahead and actually call that method. So in order to do that, we're going to do test method with parameter. Whoops, did I copy the wrong one? Nope, I did copy the wrong one. We should be calling with parameter. All right. So test method with parameter, we're passing 3 along. That should go ahead and do that. So we should see here, hopefully, in test method with parameter, the test number is 3. Great. That's working essentially how I said it would. So let's check at this point that we haven't screwed up our local variable to main. So I'm going to go ahead and just toss a little print line out. So like, let's just go ahead and see that we haven't changed anything. Okay, so in main, the value of test number is still 1, in spite of all of the various versions of test number that are flying around here. They're all different places in the memory. The computer is very capable of being like, okay, this value of the word test number is inside of this function or inside of this method. And so we're going to give that one a new memory address. And in this function, the word test number will point at that, in this method, the test number will apply to that memory address. But that's not going to change the other memory addresses that have been assigned before. All right. So our next thing that we're going to want to do is we're going to want to go ahead and start changing some stuff. So this is going to be about modifying these variables, and we'll see what happens. So first things first here, I'm going to make myself yet another little test function. This little test function is called method. This little test method is called test method with a change. So this one adds 10 to test number. It doesn't take a version of this. This should be the class variable. So this is what's sometimes called a setter method. These other ones are kind of getter methods, especially this first one. What a getter method does is it just goes and sees what is in a variable and dumps it out, and a setter method goes and changes what's in a variable. So I'm going to hit run on this. We shouldn't see anything happen because we haven't actually called that change method. So let's go ahead, go back up here to the top of our program, and let's do, let's grab our test method. And this should be altering the class variable. So when we hit run here, what we should see is before the change it was 0, after the change it's 10, and let's see, let's just I'm going to delete this in a second, but let's call test method again. Remember, test method just printed out the variable or the value of the class variable, and it's still 10 now, because that method that I just did, the test method with change, that thing actually changed the class variable. Okay, so perfect. So we know how to change the class variable now. Let's go ahead and do one of the local ones. So I have here a test method with local change that I'm using. So this is essentially the test method with a local variable that we had before. That's this guy. The only difference is that now this one actually does change that value around. So let's go ahead and we'll call that. So we want to call this. And what we should note is that this isn't going to repeatedly change that value. So before the change it's 2, after the change it's 12. If we go ahead and call, let's go ahead and just call that method again. So if I call this method twice, you might expect it to be adding 10 twice. The kick of this is that because it declares that local variable in the method, this line, that's going to make a new variable every time the method is called. It's, in fact, probably not even kept in the same memory address as the previous call. And so we're just essentially discarding the changes that have been made in the past. Okay, so that's we can change, if we've got a local variable, we can change it without there being permanent consequences. However, if we're playing with the class variable, right, that's this one, there will be permanent changes. All right, let's go ahead and grab our parameter, and we'll grab that one and do some changes in there as well. My hope is that you'll expect that this probably acts a lot like the previous one, and it should. There's no reason that it should act different than the previous one. So let's go ahead and grab a function call for that up here. Sorry, a method call for that up here. And let's go ahead and run it. So here we're getting, before the change it's 3, after the change it's 13. If we call that again, should see that same thing because that variable is reinitialized. So it's essentially forgetting what happened before. Really, because a new method call is a new set of variables, unless it's using variables that are above it in scope. Okay, and then let me just confirm one thing here. So last thing I'm going to confirm is after all shenanigans that have been tested and done in main, right, we had this variable that was local to main That one should be 1. I've never changed that. I've changed a whole bunch of values of a whole bunch of variables named test number, and we never changed the one that was in main because we never actually altered it in here. We did lots of changes, right? We did one set of changes to the class variable. We did sets of changes to both different versions of having a local version of that test number variable, but we never actually changed the one in main. So I hope you can see that there's like a whole bunch of different versions of a variable that might exist in your program. Even using the same name is not necessarily a problem. Uh, this gives you some freedom. It can occasionally be a bit confusing when you're wondering why something didn't change. If it didn't change, it's probably a scope issue. If you can't find the value of a variable, it's oftentimes also a scope issue. Usually you need to pass it along as a parameter or somehow point it at that variable, which is a topic that takes some time to figure out. Thanks for watching this one. I will catch you guys on the next one.